Hello dear students, in this video I'll continue with the 8th chapter, which is linear programming problem. In this video we'll see the questions from 7 to 9 of section 8.6 check your progress from the CBSE Handbook. I have already solved the first 6 questions of this section. The links are available in the description. Here we have the 7th question from section 8.6 check your progress. We have to solve the following linear programming problem graphically by using isocost method. Here in this 7th problem we have minimum z is equal to 4x minus 2y. Here the coefficient of y is a negative integer, so I am saving this question which can be done at the last. Moving on to the next question. We have to solve this using isocost or isoprofit method. Maximize z is equal to 3x plus 9y subject to the constraints x plus 4y less than or equal to 8, x plus 2y less than or equal to 4 and x and y greater than or equal to 0. So here the first step is we have to formulate the given LPP. This is already formulated. The second step is we have to find the feasible region, that is the region which satisfies all these constraints, and then we have to mark the corner points. If the feasible region is bounded, then the maximum or the minimum value of z will occur at one of the corner points. Here we have maximize z is equal to 3x plus 9y. Since this is a case of maximizing the objective function, we have to draw the isoprofit lines and we have to choose that line which is farthest from the origin as the line which maximizes z. Now let us proceed with this problem. First we have to find the feasible region, that is the region which satisfies all these constraints. So let us take a graph sheet, mark the x-axis and the y-axis. And then first let us find the region corresponding to the first inequality, x plus 4y less than or equal to 8. To find the region corresponding to the first inequality, we have to draw the line x plus 4y equal to 8. Now to draw the line x plus 4y equal to 8, we need any 2 points, so that if we join those 2 points, we will get the line corresponding to x plus 4y equal to 8. The easy method is we can give x as 0 and we can find y. When x is 0, we will get 0 plus 4y equal to 8. So y will be 8 by 4, which is 2. So when x is 0, y is 2. And the next point we can give is, we can choose y as 0. When y is 0, we get x as 8. So these are the 2 points. So if we mark the points 0, 2 and 8, 0 on the graph sheet, and if we draw the line joining these 2 points, it is the line x plus 4y equal to 8. So here on the x-axis and y-axis, let us take the scale as 1 centimeter equal to 1 unit. So the point 0, 2 is here and the point 8, 0 is here. If we draw a line joining these 2 points, this is the line corresponding to x plus 4y equal to 8. We need the region corresponding to x plus 4y less than or equal to 8. If we check whether the origin lies in this region or not, when we substitute the coordinates of the origin x as 0 and y as 0, 0 is less than or equal to 8. So the origin lies in the region corresponding to x plus 4y less than or equal to 8. So it is this part. X plus 4y less than or equal to 8. And then we have the next inequality, x plus 2y less than or equal to 4. To find the region corresponding to this inequality, we need to draw the line x plus 2y equal to 4. Again, we need any 2 points of this line. So when we take x as 0, we get x as 0, 2y equal to 4. So y will be 2. The next point is when we take y as 0, this part will be 0, x will be 4. When y is 0, x is 4. So this is 0, 2 again, and 4, 0 is this point. So if we draw a line joining these 2 points, we will get x plus 2y equal to 4. We need the region corresponding to x plus 2y less than or equal to 4. So if we substitute the coordinates of the origin and check, when x is 0, y is 0, 0 is less than or equal to 4. So the origin lies in the region corresponding to this inequality. So it is this part. This is x plus 2y less than or equal to 4. So the feasible region is, and then we have the non-negative constraints, x greater than or equal to 0 and y greater than or equal to 0. It is the first quadrant. So the region which is common to all these constraints is the feasible region. It is this part. So this is the feasible region. So here we have the corner points of this feasible region, O, A and B. So this is A, the coordinates for this is 4, 0, and this is the corner point B, the coordinates for this is 0, 4. And now if we have to find the maximum value of the objective function z, we have to draw the isocost line. So first we have to start with an arbitrary value of z. Now to determine this arbitrary value, let us take the LCM of the coefficient of x and y. The coefficient of x and y is 3 and 9. LCM of 3 and 9 is 9. So for simplicity's sake, I am choosing the arbitrary value for z as 27. So let us draw the line corresponding to 3x plus 9y equal to 27. Again we require any 2 points on this line. So when x is 0, this part becomes 0. You will get 9y equal to 27 or y is equal to 3. Then when y is 0, this part will be 0. We get 3x is equal to 27. X will be 9. So the 2 points are 0, 3 and 9, 0. This is 9, 0. So if we draw the line joining these 2 points, we will get the first isocost line corresponding to isoprofit line. Here the objective function is to maximize z. So we will get the isoprofit line corresponding to 3x plus 9y equal to 27. So this is the isoprofit line. So the value for this line is z is equal to 27. And now to find the isoprofit line that will maximize z, we have to draw the line which is passing through the origin. That is the isoprofit line which passes through the origin and has the value for z as equal to 0. Now let us draw lines which is parallel to this line and passing through each of the corner points. So here this is the next line which passes through this corner point, and this is the next parallel line which passes through this corner point. So here we can see that this particular line is farthest from the origin and it passes through this corner point. As a result, this corner point B 0, 2, it maximizes z. So B 0, 2 maximizes z. So we get x is equal to 0 and y is equal to 2. The maximum value of z is 3x plus 9y. The maximum value for z is 3 into 0 plus 9 into 2. It is 18. So this is the maximum value for z. So here we have the result. The coordinates x is equal to 0 and y equal to 2 of corner point B satisfy the given constraints, and the total profit obtained is z is equal to 18. So this is the optimal solution and the maximum value of z. Moving on to the next question. Again, this question also we have to solve using isocost method. Maximize z is equal to 3x plus 2y subject to the constraints minus 2x plus y less than or equal to 1, x plus y less than or equal to 3, x less than or equal to 2, and x greater than or equal to 0, y greater than or equal to 0. So let us proceed to find the feasible region for this, and let us solve this using the isocost or isoprofit method. So let us draw the x-axis and the y-axis on the graph sheet, and now let us find the region corresponding to each of these inequalities. The first inequality is minus 2x plus y less than or equal to 1. To find the region for this inequality, let us draw the line minus 2x plus y equal to 1. So the 2 points that we require, when x is 0, this part becomes 0, so we get y is equal to 1. When x is 0, y is 1. And then when y is 0, this part will be 0, x will be minus 2x will be equal to 1, or x will be minus half. So x will be minus half. So the 2 points are 0, 1 and minus half, 0. So let us take the scale as 1 centimeter as half unit. So here we have 0 0.5, 1, 1.5, 2, 2.5. The y-axis also we have the same scale, 0.5, 1, 1.5, 2, 2.5, 3. This minus half, it is nothing but minus 0.5. So 0, 1, this is 0, 1, then minus 0.5, 0, it is this. This is minus 0.5, 0. Now let us draw a line joining these 2 points. This is the line corresponding to minus 2x plus y equal to 1. So this is the line joining the points 0, 1 and negative 0.5, 0. So this is the line corresponding to minus 2x plus y equal to 1. Now we need to know the region corresponding to minus 2x plus y less than or equal to 1. So if we substitute the origin and check, the coordinates for the origin is 0, 0. When we put x as 0 and y as 0, we will get 0. It is less than 1. So the origin lies in this inequality. Minus 2x plus y less than or equal to 1. So it is this part. So this is the region corresponding to minus 2x plus y less than or equal to 1. Next we have the next inequality, x plus y less than or equal to 3. Now to know the region corresponding to x plus y less than or equal to 3, let us draw the line x plus y equal to 3. So to draw the line x plus y equal to 3, let us take when x has 0, this part becomes 0, then y will be 3. The next point is, let us take y as 0. If we put y as 0 here, we will get x as 3. So if we draw the line joining the points 0, 3 and 3, 0, we will get x plus y equal to 3. So this is 0, 3 and this is 3, 0. So if we draw a line joining these 2 points, we will get, this is the line x plus y equal to 3. So I forgot to write the equation for this line. It is minus 2x plus y. We have the inequality, it is less than or equal to 1. So this is the line corresponding to x plus y equal to 3. To know the region corresponding to x plus y less than or equal to 3, if we substitute the coordinates of the origin and check. 0, 0, 0 is less than 3. So the region corresponding to x plus y less than or equal to 3, it is this part. And next we have x less than or equal to 2. The region corresponding to x less than or equal to 2, if we draw the line corresponding to x is equal to 2, we will know the region corresponding to x less than or equal to 2. So x is equal to 2 is a straight line passing through 2, 0 and parallel to the y-axis. So this is the line x is equal to 2, x less than or equal to 2, it is this part because origin lies in x less than or equal to 2. Next we have the non-negative constraints, x greater than or equal to 0, y greater than or equal to 0, it is the first quadrant. So the feasible region is this part. Let me remove these arrows so that the feasible region will be clear. So this is the feasible region. This is x less than or equal to 2. And now that we have found the feasible region, we can identify the corner points of the feasible region. The corner points of the feasible region are, this is O, next we have A, then B, C and D. So these are the corner points of the feasible region, O, A, B, C and D. Here we can see that the objective function is to maximize Z. So we have to draw the isoprofit lines. So we have to start with one isoprofit line by giving an arbitrary value for Z. It will be easy if we choose this arbitrary value as the LCM of the coefficients of x and y. So the LCM of 3 and 2, it is 6. So LCM of 3, 2 is 6. So let us give the arbitrary value for Z as 6 and draw the first isoprofit line corresponding to Z is equal to 6. That is 3x plus 2y equal to 6. So if we have to draw the line corresponding to 3x plus 2y equal to 6, we need the 2 points. Let us put x as 0. So this part will be 0, 2y will be equal to 6 or y equal to 3. So when x is 0, y is 3. Next let us put y as 0. When we put y as 0, this part will be 0. We will get 3x is equal to 6 or x is equal to 2. So the next point is 0, 2. Now 0, 3 is this point, and next we have the next point 2, 0. It is this point. Now let us draw a line joining these 2 points to get the first isoprofit line. So this is the first isoprofit line corresponding to Z is equal to 6. Now the next step is we have to draw lines parallel to this line passing through each of the corner points, and we have to find that line which is farthest from the origin. So for that, let us draw the line passing through the origin. So if we draw lines parallel to this line and passing through various corner points, we can see that this line, it is the line which is farthest from the origin. So this is the required isoprofit line. Here if we see, each point on this line will have the same value for Z. That is the reason why we call this line as isoprofit line. Iso means same. Now to know the value of Z, we can find the coordinates for B. If we find the coordinates for B and if we substitute the value of x and y, we will get the maximum value for Z. So if we see the coordinates for B, B is the point of intersection of the line x is equal to 2 and x plus y equal to 3. So here the x coordinate is 2. B, it is the point of intersection of the lines x is equal to 2 and x plus y equal to 3. So the x coordinate is 2. If we put x as 2 here, we get y as 3 minus 2, it is 1. So the coordinates for B is 2, 1. So this is the coordinate for B. Here we can see that the corner point B 2, 1, it maximizes Z. So Z is 3x plus 2y. When x is 2 and y is 1, we get the value of Z as 8. So the maximum value of Z, it is 8. Here we have the result. The coordinates x is equal to 2 and y equal to 1 of corner point B satisfy the given constraints, and the maximum value of Z obtained is Z is equal to 8. So all these can be done in the rough. It is important that we draw the graph and write the result. So here in this problem and in the previous problem, we have seen that the isoprofit lines, or if we have a minimization objective function also, in the previous video the questions that we have seen, all the objective function, the lines of the objective function, that is the isoprofit or isocost lines, had negative slope. That is, the slope was like this. So when the slope was negative, we choose that particular line which is farthest from the origin, that is farthest from the origin, as the isoprofit line. That is, that particular line will maximize z, and that line which is nearest to the origin, it will minimize z. This is what we have seen in the problems so far. Now we have the seventh question. It is minimize z is equal to 4x minus 2y subject to the constraints x plus y less than or equal to 14, 2x plus y less than or equal to 24, 3x plus 2y greater than or equal to 14, and x and y greater than or equal to 0. Now this objective function has the coefficient of y as a negative integer. So in this case, the isocost line which we draw, it will not have a negative slope. It will have a positive slope. It will have slope like this. So this is a positive slope. When the slope is positive, then we cannot use the steps that we have seen in the isocost or isoprofit method. That is, we cannot use the line which is farthest from the origin will maximize z, or the line which is nearest to the origin will minimize z. Or let us proceed with this problem. So the first step is we have to find the feasible region. So let us take a graph sheet, mark the x-axis and the y-axis. So we have the constraints x plus y less than or equal to 14. So let us draw the line corresponding to x plus y equal to 14. When x is 0, y is 14, and when y is 0, x is 14. So let us take the scale as 1 unit is, 1 centimeter is 2 units. So it is 2, 4, 6, 8, 10, 12, 14, 16 and so on. Here also in the y-axis also we are taking the same scale. So to draw the line corresponding to x plus y equal to 14, we have the points 0, 14, it is here, and 14, 0 is here. If we draw the line joining these 2 points, we will get x plus y equal to 14. This is the equation of this line. Now to know the region corresponding to x plus y less than or equal to 14, the origin lies in this region. When we substitute x as 0, y as 0, 0 is less than 14. So the region corresponding to x plus y less than or equal to 14 is this part. Next we have the next inequality, 2x plus y less than or equal to 24. So let us draw the line corresponding to 2x plus y equal to 24. When x is 0, this part will be 0, y will be 24. Then when y is 0, this part will be 0. 2x will be 24, x is 12. So we have 0, 24 here and 12, 0 here. So if we draw a line joining these 2 points, we will get the line corresponding to 2x plus y equal to 24. The region corresponding to 2x plus y less than or equal to 24, it is this part. Next we have the next inequality, 3x plus 2y greater than or equal to 14. So first we have to draw the line corresponding to 3x plus 2y equal to 14. So when we have x and y, when x is 0, this part will be 0, 2y equal to 14 or y is 7. Then when y is 0, this part will be 0, 3x is equal to 14 or x is equal to 14 by 3 or it is 4.7. So the points are 0, 7, it is here, and 4.7, 0, it is somewhere here. It is here. So this is the line corresponding to 3x plus 2y equal to 14. Now we need to know the region corresponding to 3x plus 2y greater than or equal to 14. When we substitute the origin and check 0, 0. 0 is not greater than 14. So it is the other side of this line. 3x plus 2y greater than or equal to 14 is this part. The equation for this is 2x plus y less than or equal to 24. It is important that we have to write the equation of the lines on the graph sheet. So now the feasible region is the region which is common to all these. The non-negative constraints x greater than or equal to 0, y greater than or equal to 0 is the first quadrant. So this is the feasible region. So this is the feasible region. Here we can see that the feasible region is bounded. So the maximum and the minimum value of z will occur at one of the corner points. Let us mark the corner points. So the corner points are A, B, C, D and E. Now we know the coordinates for some of the corner points. For A it is 4, 0. For B it is 12, 0. C it is the point of intersection of these two lines. Since we have drawn this on the graph, we can see that the coordinates for C is 10, 4. The x coordinate is 10. If we draw a line, perpendicular line to the x-axis, here we can see that it is 10. So x coordinate is 10. And if we draw a line perpendicular to the y-axis, we will get the y coordinate. It is 4. So the coordinate for C is 10, 4. For D it is 0, 14. And for E it is 0, 7. So this is the coordinate for each of these corner points. And now we have to draw the isocost lines. Since this is a minimization problem, the lines which we draw are called the isocost lines. So we have to give an arbitrary value for z. It will be easy if we take the LCM of the coefficients of x and y. So LCM of 4 and 2, it is 4. So let us give an arbitrary value for z as 4 and draw the line corresponding to 4x minus 2y equal to 4. When x is 0, minus 2y equal to 4 or y will be equal to minus 2. Then when y is 0, x will be equal to 4x equal to 4, x will be 1. So the point 0, minus 2, it is here. So this is minus 2. This is the point 0, minus 2. And next we have 1, 0. 1, 0 is here between 0 and 2. So if we draw the line joining these 2 points, we will get the first isocost line whose value of z is 4. So this is the first isocost line. This is a line corresponding to 4x minus 2y equal to 4 and the value of z is 4 in this case. And now let us try to draw lines parallel to this line, which is passing through each of the corner points. So if we draw lines parallel to this line passing through each of the corner point, we have to see the line which is nearest to the origin, that is the line passing through the origin. So the line which is passing through the origin is this line, and the line which is nearest to this line is this isocost line. So if we substitute the value of x and y, we will get the value of z as, here the value of x is 0 and y is 7. So for this line we will get the value of z as negative 14. But here we can see that for this corner point D, 0, 14, we will get the value of z as, when x is 0 and y is 14, in this case we will get the value of z as negative 28, which is lesser than this value. So the minimum value of z will occur at this point and not at this point, that is, it is not corresponding to the line which is nearest to the origin. The reason being, here we can see that the slope is positive. If we have a negative integer coefficient in either x or y, it is better to proceed with corner point method itself to find the maximum or minimum value of z. We may not get the right result. So let us proceed with corner points. The value of z is 4x minus 2y. The various corner points are a 4, 0, b 12, 0. Let me write it with the blue pen itself. This is a 4, 0, b 12, 0. This is c, d and e. C 10, 4, D 0, 14 and E 0, 7. So if there is a negative integer as coefficient for x or y, sometimes we may get right result, sometimes our result may not be right. So let us proceed with the corner point method. So when at this corner point a 4, 0, the value of z is 4 into 4, 16. At this corner point b 12, 0, the value of z is 12 into 4, 48. At the corner point c 10, 4, the value of z is 40 minus 8, it is 32. At this corner point d 0, 14, the value of z is minus 2 into 14, it is minus 28. And at this corner point E, x is 0, y is 7, the value of z is negative 14. So this is the minimum value for z, and it occurs at the point D 0, 14. So this is the optimal solution, and the optimal value for z is minus 28. So here the coordinates x is equal to 0 and y equal to 14 of corner point C satisfy the given constraints, and the minimum value of z obtained is z is equal to negative 28. Again, if we see, these questions are hypothetical questions, and here again the slope is positive. We are using the corner point method to find the minimum value of z. Since here the slope is positive, here we can see that the coefficient of y is a negative integer. So if we move to the left side of the origin, the value of z will decrease, and if we move to the right side of the origin, that is, if we move the isocost lines to the right side of the origin, the value of z will increase. So we have used the corner point method to find the optimal value of z. I hope this video was useful for you. With this, I have completed all the exercises from chapter 8, linear programming problem. The links for the other questions are available in the description. If you have not subscribed to my channel, please subscribe. Thank you for watching.